Now my next topic is various 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 forms of equation of straight lines. Various forms of equation of straight line. Now your first is that equation of a line passing through a given point. Equation of a line passing through a given point. So here you see that this is equation of a line passing through a given point. Here this is the point. Say let this be the point, say x1, y1. Now what I do here is that I take an arbitrary point, say P, that is xy. Now the slope of this line, this L, slope of this line will be m, that is y minus y1 by x minus x1. Because you have learned that to find the slope of a line when it passes through 2 points is, you have learned this formula, that is m is equal to y2 minus y1 by x2 minus x1. So here this is the slope of this line. This is given to you, and this is an arbitrary point which I have selected. So your y minus y1, that will be equal to m x minus x1. So this is the equation of this line passing through a given point. So I repeat, this is the point given to you, and this is an arbitrary point which I have selected, and you know that the slope of a line passing through 2 points is formula is this. So I have applied this formula, and you cross multiply it, you get this is the equation of this line. Now equation of the line passing through 2 given points. Equation of a line passing through 2 given points. Of a line passing through 2 given points. Equation of a line passing through 2 given points. So here you see that this is the line which is passing through 2 given points, that is A, that is x1, y1, and this is B, that is x2, y2. So now you can solve it. So before doing this, I would like to solve one formula, that is point slope form. Point slope form. Point slope form. That means point slope form, which is given as here in your textbook, it is given as point slope form. Let me take, it will be better if I take this as point slope form. That means here this is a line, and passing through this point, that is A, x1, y1, and the slope of this line is given, that is m. Now we take another point, that is B, this arbitrary point xy. So here slope m, that will be equal to y minus y1 divided by x minus x1. This will be equal to m x minus x1 is equal to y minus y1. So this comes out to y minus y1 is equal to m x minus x1. So the equation which I derived just earlier, it was the same, that that we call it at the to find the equation of a line passing through a given point. That can be considered as also point slope form. That means an equation, a line which passes through a point and the slope of this line is given. So you can consider that which was derived earlier, that is the equation of a line passing through a point, that can be considered as point slope form. That means this statement clarifies the point, that is the line passing through a given point, and slope, that is the slope of this line, is given to you. So your equation is this. Now equation of a line passing through two given points. Because this equation is very helpful, it helps you to find out the formula of other equations. Now equation of a line passing through two given points. So here you see that this is the line which is L, which is passing through a point. Let this be x1 y1, and another point, that is B, that is x2 y2. So now your slope, that is m, will be equal to y2 minus y1 by x2 minus x1. So now you have found out the slope. You can consider this as a point, given point. This is given, already given. So you can apply the formula point slope form, that is y minus y1 is equal to m x minus x1. So now here y minus y1 and the value of m is y2 minus y1 by x2 minus x1 x minus x1. So this is the equation of the line. I am repeatedly telling to you that the first equation which I derived, that is the equation of a line passing through a point, that is also considered as point slope form. If you take the point slope form of passing through a point and the slope is given to you, then your equation is this. This equation helps you in finding out other equations, because here you know the slope, you know a point, so you can apply this formula, point slope form. So when I apply this formula, this becomes the equation of a line. Now my next, this is gradient form, which is given in your book, gradient form. In your book it is equation of a line in gradient form. It is given to you in gradient form. That means here it is given equation of a line in gradient form. So here you may consider this as slope intercept form. You may consider this as slope intercept form. You may consider this as slope intercept form, because now here you can see that this is the equation, this is the line which is intercept, means y-axis. It is making an intercept and y-axis 0, c, and the slope of this line is given to you. So again you can apply this point slope form. So when you apply this point slope form, that is y minus y1, is equal to m x minus x1. So you know this point. So this is y minus c is equal to m x minus 0. So y minus c is equal to mx. So y is equal to mx plus c. So see, it becomes very easy to derive all the formula from the first formula, that is point slope form. By the help of point slope form, you can derive all other formulas. This becomes very easy. But in your book, um, this derivation is given a little bit of a different way. Let me do it for you. A different way. It is the same thing, but they have done in a little bit different way in your book. Here, what they have done is that they have considered a line. This is the line L, which makes an intercept on the y-axis. It makes an intercept on the y-axis, that is at here. So its coordinate is 0 comma c. It makes an intercept at a y-axis, and now and this line makes an angle theta with in anti-clockwise direction parallel to x-axis. This makes an angle theta uh, parallel to x-axis in anti-clockwise direction. Here a point P is considered, that is xy. So now you see that this is x and this is y, and here y, and this is your c. So this is equal to y minus c. This is y minus c. So this is x again, because this is a rectangle. So your slope tan theta is equal to perpendicular by base. So y minus c by x tan theta, that is equal to perpendicular by base, and this is m is equal to y minus c by x, that is mx is equal to y minus c. So y is equal to mx plus c. They have derived this equation in this way. So here in your book, it is considered that a line which cuts the y-axis at 0, 0c, and it makes an angle theta in anti-clockwise direction parallel to x-axis, and P is an arbitrary point whose coordinates is xy is taken. So here you see this is x and this is y, this is c, so this will be y minus c. Here this distance y minus c, and this is a rectangle, so this is an x. So tan theta is equal to perpendicular by base, so the perpendicular by base, and this is your answer. They have solved it in this way. So now the next is the equation of a line in intercept form. Equation of a line in intercept form, that is means the lines cuts both the axes. Here in x-axis a comma 0, and in y-axis, that is 0 comma b. To find out this equation, you can take the help of the equation passing through two given points. Y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. You can take the help of this equation. So here you can consider, it is up to you, you can consider this as x1 y1 and this as x2 y2, or you can consider this as x1 y1 and this as x2 y2. There will be no difference, no effect in finding out the equation of a line. So here I have considered this as x1 y1 and this as x2 y2. So y minus 0 is equal to b minus 0 by 0 minus a, that is x minus your a. This is it. So here y is equal to minus b by a, x minus a. So ay is equal to minus bx plus ab. So this is equal to ay plus bx is equal to ab, dividing both sides by ab. So this will be ay plus bx by ab equal to 1. Now this will be equal to y by b plus x by a equal to 1. So x by a plus y by b equal to 1. This is the equation of a line in intercept form. This is the uh, equation of a line in intercept. This is the equation of a line in intercept form. In intercept form, that means it is the line is cutting the both the axes, x-axis and y-axis. In the x-axis at point a comma 0 and in y-axis at 0 comma b, and you can take the help of the to find out this equation. You can take the help of the equation of a line passing through two given points, and you can derive this formula. Now my last is the equation of a line in normal form. Equation of a line in normal form. So here you see that equation of a line in normal form. This is the line, it is given to you, and the perpendicular distance from the origin P, this is given to you, and this perpendicular distance in anti-clockwise directions makes alpha, because in coordinate geometry angle is always calculated in anti-clockwise direction with respect to x-axis. So here this is A, this is B, this is C. Now let us consider in triangle OAC. Here cos alpha is equal to base by hypotenuse, that is OC by OA. So OA is equal to OC by cos alpha. So this will be OCP by cos alpha. So the coordinate here is, this is P by cos alpha comma 0. This is your coordinate. Now let us consider in triangle OBC, this angle will be equal to how much? 90 degree minus alpha. So this is again cos 90 degree minus alpha. This is base by hypotenuse. So this will be OC by OB. So this is sin alpha. This will be equal to OC by OB. So here OB is equal to, that is OCP by sin alpha. So here your coordinate of B is equal to 0 comma P by sin alpha. Now here I can use the help of this intercept form. So according to intercept form, x by a plus y by b is equal to 1. So here x by a, your a is this P by cos alpha, plus y by b, this P by sin alpha, that is equal to 1. So x cos alpha by P plus y sin alpha by P is equal to 1. So x cos alpha plus y sin alpha is equal to, this is P. So this is the equation of the line. So normal form. So this is all about the various forms of the equations of the line and how you are going to derive it.